Hello everyone. Today we're gonna come up to the last, only the conceptual and content for the class. As I mentioned before, that there are one last thing that I cannot ignore and have to include into the class itself is called hashing. And right now I'm gonna talking more only about the concept of it. But then before we can talking about hashing, I think we should go back to recap a little bit about the fact of overall recap. I think first of all we need to understand some fact that data structure, as we mentioned and always I always mention that is created for some specific purpose. So for example, if first of all like you need to design the data, the collective of the structure to be able to collect every single information that you want it to be. So that's why in C or in Python itself, they have something called struct, right? So struct itself is the first key idea that is used for design the collective information depends on the application that you want. For example, if you want to have the data structure that represent the the address or phone numbers of specific person, then at least inside the struct is need to have the string that contain the name of person and the array of integer, for example, to contain phone numbers, another array of integer to contain address numbers, or and so on. So that's why the struct provide the flexibility for you and for everyone to design the data structure depends on what they need in the time that they really need it. And then follow through that, the second thing that we learn in the class itself is how to provide the flexibility to that structure. So two main core concepts of the class is going to be either how to use pointers and how to extend it into big different way, the dynamical way or predefined way or like static one. So how to work around it is that the concept of pointer provide flexibilities toward almost everything. So starting from pointer itself, you can draw two main data structure that you can playing around. The one that you point to only the starting of the area, you point it only here, and then you sequentially count the index of information. This one, as we know, we call it array, right? It's going to be array of some things. Good thing about array is it's quick. It's quicker in comparison to linked list. For sure, if you're searching for information within array itself, it doesn't have to point to another space. It's easier to implement. The problem is it cannot provide a dynamic size because we need to allocate all the space in the memory beforehand. If you define the array of stock of the size of 50 index, then you need to provide the space that big enough to contain all of that sequential chunk in your RAM. And in current world, I would say like in nowadays world, if your data is not that big, it's not gonna be difficulty to do that. Because right now, if you run even in your laptop, you can provide the array of some structure that contain integer and string for more than like 1,000 or 10,000 size of array. That's gonna be feasible within the current modern day technology. But whenever you come to the real industry that you have limited memory size, for example, you work around the microcontroller, the control board in the industry, or you work with too big size of data, like you work in telecommunication kind of industry. The problem becomes, and within that problems, the way we work around is that we trying to use some dynamic allocation of memories, in which that you have pointer that point to, you have like this kind of shape of data structure. You have pointer that point to one side or another side of the structure, and here is the information itself. So that's one is the main concept of linked list, right? You have a block, you have a node of information that have the pointer that pointing around, either on the left, on the right, or even like more than two direction. So that's gonna be linked list. So good thing is linked list provide more flexibilities. The problem is it's harder to implement. It's need to design some algorithm to work around it, and the problem about space also came in as well, because like the larger side of the linked list is mean you need to have the space for contain more pointers, and for some kind of advanced design of linked list, it might contain quite a lot of space, like around 10 or 15% of storage space that you need to devote it for just store the pointer itself. And then from that to backbone of data structure, you can design many fascinating things, starting from queues, stack, trees, right, and try that you just learned before. So those concepts can be worked around by linked lists and arrays. Depends on the way you implement it, but then you're gonna see some more limitation in array. You get more flexibility in linked lists, but then in array is gonna be faster. So whenever you have information, then in the end, at the end of the day, you make it for work on it. So you need to be able to store it, right? You need to be able to store and insert new information. What else? You need to be able to delete it. You need to be able to search for it, and you need to be able to sort the data that you have in your collection. I mean, this kind of like very basic property that you might need to have, at least in any kind of your work around the data structure itself. Because without those kind of features, then why we need to collect a lot of data together? It's not going to make sense, right? Then it's come to the fact that you need to select the data structure or design of the structure itself that's suitable for what you want it to do. For example, if you want the data to be quickly sorted or quickly searched, then you're gonna see like by search and sort algorithms in different one. You need the linked list, you need array, you need trees, in which create specifically for searching information much faster. For example, like heap binary trees that create for searching for maximum and minimum numbers as quick as possible. Those kind of design is designed for serving two properties. It's gonna have like two main properties that everyone gonna be concerned, right? It's about storage size. Another thing is speed or computational power, computational times. In those two, it's gonna be two things that you need to rebalance, like fighting back and forth, which one you're gonna concern more or less, and then you try to tie it up together. And I think in the past you're gonna say like in some application one gonna benefit more than others. That's the recap of overall of data structure itself. Then whenever you select you're gonna be in charge of design your program, selecting computational power and data structure that you're gonna use, then in that specific times you need to think like in this kind of logic. which one you're gonna select it is depends on which feature that is the main feature of that work. For example, in some kind of work, you're just searching for more information, you're not delete it at all. You don't care about deletion, and search and sorting is the frequent thing that you're gonna do. You barely insert new information or barely delete the information, then you just design the structure to be as fast as possible for search and sort. And in some application you need very limited storage size, then you cannot use linked list at all because it's easier to use array and control the size. Or if you want to use linked list, you're gonna use the way that you frequently delete information and insert new information, not make it expand too big, but you will still be able to control the size in quite solid way. Okay, so that's kind of idea of the class itself in general. Then today we're gonna talking about the last things, and you're gonna use it a lot, especially in database kind of application, that you want to maximize the speed. You don't care about the size. Okay, in this data structure we much more concerned about the speed. We want it to be able to search for for new information as quick as possible, and also we want to be able to we ignore the sorting as well. We just want it to be able to search as quick as possible. That's come to the name of hashing itself. We posted as a cheat sheet for you guys. Hashing, as I mentioned before, is mainly for the speed of searching. Then thinking about how to make it fast enough to searching for more, like the information, any kind of information as quick as possible. Then I think you might thinking about array, because like so far, if we thinking about the structure of anything, array itself is gonna be the one that you use only one pointers, and then you count the number, the index in sequence. Then you can point to each specific index in array in the same speed, and that's kind of fascinating property of array. However, in complex things, in general, for example, like if you have the name of person and you want to searching for their telephone numbers, how are we gonna do that? Okay, then it's come to the fact that maybe we need to have any kind of function that change specific value, for example, like the name of person to be the index in array, index number in array. Then you just compare for checking just one more time, then you can return the value that you want. If we think about that example, then you might have the structure itself that contain two things like name and telephone numbers. Then it can be something like John and his telephone number. Like I just typed down random numbers here. Okay, that's kind of particular format. Then the issue is that whenever I searching by John, I want to get this number as quick as possible. That's come to the concept that we call hashing table. It's come to big name like hash table, in which work correspondingly to something that we call hash function. So what does it look like? Then we come to this one first. Hash table itself is something that similarly to array, like it's one big array, but you imagine that it looks like a big spreadsheet table in Excel. So the first column of this array should be index. Okay, you're gonna have array that start by index. It's gonna be index in array from 0, 1, 2, 3, and so on. then you're gonna have something that we call key and value. We have key and value. In this one, key gonna be name of person, right? And value is gonna be telephone numbers. Okay. Then by anyhow, you should be able to change John names to be index numbers. And then you store information here that, for example, like one refer to John and his telephone number. So whenever you're searching for John, this word John will go through something that we call hash function. And hash function itself will return index. Then it's come to one big question, like how to design hash function. Because you can imagine that hash function have to be as simple as possible, that can translate everything to be some specific numbers in which we're gonna refer to the index of array. So only for design hash function can be one big class. Because to design it like in the most effective way, you need to understand math and algorithm properly to use specific mathematical operators that can transfer each specific value to be numbers. Okay, right now we're gonna use something that easy enough to make it to be hash numbers. So we're gonna use modulo. If you remember, modulo is mean if you divide some numbers with that specific modulo based number, then you return what you get as like undividable part of that number. For example, like you have 20 mod 4, then it should equal to 0. Oh, sorry. Right. However, if you have 9 and then you mod 4 is equal to 1. That's kind of idea. Then modulo itself work extremely quickly. If you in future you're gonna learn about computer architecture, they have one unit called ALU, which is arithmetic logic unit, and that's one is some kind of circuit that designed specifically to calculate modulo plus minus as quick as possible. So modulo function work quickly, and the name quickly is mean it should be able to work for hash function. Then how we gonna change John names to be number, and then you will be able to mod it. The idea is that you change John to be the ASCII code, the summation of ASCII code between JOHN. Then you have some numbers, and then you mod it by the size of your hash table that you want to get. So for example, if you from these two ideas, if you want to have hash function, then you need to create the way to change input to be number, and then you divide by n, which is size of hash table, and then it's going to equal to the index that you store the information. Then by this equation you can change all text back to be the index if you have hash table of size 500. Okay, then you can change any kind of names in string to be ASCII numbers, and then from the ASCII number you modulo it, and then you're gonna have index. And then in that index you store information in prior. You store the name John and you store this number as their telephone numbers. Then whenever you're searching for John, you put John in this equation again, you get the index, you go to that index in array, and then you return the value. Not return the key, you return only value. Then why we need to store the key? It's because by this function, it have high possibilities that the summation of numbers here mod by the size of hash table gonna return the same integer. Again, by this example, if I modulo y4, if I sum the value of the ASCII code and it have something like 1681, that's the summation of the text in the name of one person, and I modulo by 4, is still equal to 1. And when you abstract it down to be 9 or 1681, you don't know anymore which person is which. And if it still refers to the same index, you not really know that you return the correct value or not. Then you just simply compare the key with input. So another step that you need to do is you compare key with input. If true, you return value. That second step that you have to do to reconfirm that you retrieve correct value. Okay, it's still quick, extremely quick. You just do one if comparison and then you return value, but then you can jump to that index immediately because of this equation and the property of array. Then you can see like why I mentioned that hash, even though it look like extremely good, it can retrieve data as fast as possible, but you can see like you need to have very big, pretty big storage. That's why if you have like database system that use hash table, it's gonna be able to retrieve data extremely quick, but then you need to have big storage size, and that's why a lot of database system contain a lot of storage. It's like storage eaters. It take much bigger space than it should, because that is a trade-off for the speed of hash function. Okay. Then next step is like what will happen if you have like two things. For example, if this number 9, if I change John and it's go to number 9, and then I change some name like super what, for example, and then it's go to 1681, then where super what go? That's question, right? Because like okay, it's referred to same index. Does it mean that we cannot store the information of super what, or we can store only information for John? That's become the problem in maths, because you use this kind of quick function to translate text to some index, right? Then we need something to be able to count down, and it should be, again, it should be very simple logic, very simple algorithm that you implement it quickly, and it should be work as quick as possible. If not, it's gonna slow down the whole hashing table. Then the ideas that we use it nowadays is something that called linear probing. So linear probing gonna use for just for resolve this issue. It's not solve any problem, but for resolve it, it's possible. So the way it works is that if you insert one information in that index, then if you modulo the value and you get the same index you're searching for that value, then again you check that the key is empty or not. Right now the key is already been acquired by join information. Then the way linear probing do is they advance to the next space in the array until it go to the space that empty. Then they store the information of super 1 right there. Right here, for example, then I might say like they have the information of Smith here, which is mean like okay, they cannot store information of super 1 in John. They advance to number 2 index. They already have Smith here. They also advance to number 3 index, which is doesn't have any information so far. That is the space that super 1 go, and then this information of super 1. That's why here they will have another step as well when you're searching for information. Okay, I should mention here that this one is searching. If you're searching for information, you're gonna do step 1, step 2, and then step 3. If false, advance the probe. Pointer one step further. Okay. And then by you advancing this, you repeat the same things. Again, you compare the key with the input, and then if it equal to the key, then return value. If not, okay, you're gonna advance one step further. But if we write down like this, is come to the problem is keep searching through the whole table, even though there's no information in that yet. So the idea that linear probing will search until they find empty space to insert new information. In the same time, it means you searching until you find empty space. If there is empty space, it means you out of scope. Those information is not accessed yet in hash table. Why? Because for example, I have the author numbers here. Okay, I have the index like here is not good example because it's just only until 4. Yeah, maybe I should change it a little bit, but just imagine that you have one names in like Kajanwood, like my name for example, and then it should be index number 3, but then it's come to number 3 is already have name of Supawat. Then we advance pointer for one step, which is number 4. Number 4 is already still no information, right? And then if we found empty space, if my name, Kajanwood name, has been saved in hash table already, it should be advanced from Supawat to one step ahead, and it found empty space here and should have the name Kajanwood here with my phone numbers. However, if we searching for information but then we advance from Supawat from the index number 3 to number 4 and there's no information here, it means it's never been inserted before. That data is not accessed. That's why you need to have one step here. And you can see now that is my intention that I try to mess up this pseudocode a little bit, because you should write it down on your own for your own understanding. But then you need to check. That's also another thing that you should check, because if it is empty, then it means not that data is not accessed in this hash table at all. Again, we do the same. We do this kind of thing for searching. We also do quite similar things in insert, right? Because then we translate John Supawat Kajanwood into numbers, and then you found the index. You go to that index. If that empty, you insert that information. If it's not empty, you advance until you find empty space, and then you insert that information in. That's a pretty simple thing, which just means that if you want to delete any kind of information, it's unlike any other type of array that you can delete it and make it blank. You cannot do that. You need to shift that empty cell up. You cannot leave any empty space. If not, then when you're searching for some kind of information, it's gonna stop at the empty space. So when you cut now, it's like you cut the information in Excel, that you need to delete that cell and shift all the cell up for one row to make sure that there is no empty space in between that can break down your algorithms. That's everything about hashing. Again, I would like to mention that it's designed specifically for quick search to maximize the speed of searching, make it as quick as possible to search it. So that's why we need to use extremely simple way to resolve the problem of same index. Use minimalistic way to change any key to be the index of array. Because if you use complicated equation here or complicated algorithms here, that's gonna slow down the whole process, and it's gonna make hash not quick at all. It's gonna be slow, because like instead of modulo by 10, 50, 20, 500, 600, you use equation of, I don't know, maybe double integration of some kind of equation until you get some specific number that not have duplicated at all. It's might possible to do that in math, but it's slow, and it's going to slow down the overall process. Again, if you find a conflict between index here, and then you use the advanced algorithm to optimize the memories or whatsoever, that's going to slow down the whole process as well. That's why you need to consider in mind that hash table should be constructed by very quick to compute, very quick to compute hash function, and you need to use very quick to compute probing or resolving function when you have the conflict between index as well, to decide proper hash table that can work as quick as you imagine it should be. Okay, and this is like the simple method to do hash function that can easily implement for general kind of application. Yeah, that's all for today, and then we're gonna have the last assignment about hash table posted soon in Facebook group. And sorry for make the time a little bit intensified, but then we need to collect this homework within this week as well, to make sure that we get the score and grading on times. Okay, as you guys vote in the Facebook group. Thank you so much for today. As I mentioned, that this is not going to be the last video, even though the course is closed. I promise that I will find the time to implement all the things in code and give you kind of ideas how to change this concept back to the code, and what gonna be kind of major mistake when you implement different kind of search, sort, and data structure design that might be happens for newbie like you guys. Thank you so much, and see you around. Bye bye.